Developing new skills takes time and practice. In basketball, you may perform drills to perfect the type of shot you most often miss. In piano, you may repeat the part of a piece where you typically make mistakes. Or in chess, you may study and practice specific tactics. And in each of these cases, doing this kind of practice in low-stakes, low-cost settings is a key part of building the relevant skills. But in many domains, especially around making and craft, deliberate practice can be complicated, because on the one hand, the cost of mistakes can be high in terms of both time and material, which makes the benefits of practice very appealing. But at the same time, practice also can add material cost, so it may not even be clear how to design low-stakes practice tasks. This can make deliberate practice surprisingly rare. So the question we ask in this work is, can we use some combination of domain knowledge and computation to help guide users through practice? We examine this question specifically in the context of sewing, which is representative of a domain where practice is rare, but mistakes are common and carry a high cost, which is challenging for those learning the craft. In this work, we first conducted a formative study, which explored several strategies for low-cost sewing practice, such as using lower-cost materials and making small-scale practice pieces. We then built an interactive system for analyzing sewing instructions to estimate the difficulty of steps based on expert guidance, and recommending practice based on the difficulty of the steps and the reported skill of users, and then re-optimizing the layout of sewing patterns to incorporate suggested practice steps with minimal added cost. So we'll first take a look at our formative study, which helped inform the design of InStitches. Our formative study was motivated by this observation that practice is not a common part of sewing. One hypothesis is that it has to do with a lack of convenient ways to generate useful practice tasks, which is challenging because these tasks need to fit the competing criteria of being, on the one hand, similar to the task they approximate, while also being less costly or wasteful. Interestingly, there's one related technique sometimes used by designers to test the fit of garments, and that is to first create a mock-up of the full garment using a less expensive, lightweight material called muslin. This strategy has the nice property that it doesn't require generating new tasks. It's just performing the same task on cheaper material. But it has two downsides. First, it still requires a lot of additional material and creates a lot of waste, even if the fabric cost is lower. And second, the material itself is much lighter, which can remove a lot of the challenge that we want to practice in the first place, which may be why muslin is more often used to test fit rather than practice. So in addition to looking at how well muslin mock-ups translate to practice tasks, we proposed two new strategies that focus on using smaller amounts of the main garment material, with the idea being that most patterns generate a lot of fabric waste in the cutting process. So essentially, all of the green region on the right here gets cut away from individual pieces and is typically thrown out. But if we can repurpose these pieces for practice tasks, then we can work with the real material with even less cost and waste than something like muslin. So our formative study looked at three strategies for generating practice tasks. One was to adapt muslin for practice instead of just testing fit. And we also tested two new strategies using the main garment material. The first we call wedge, and the idea is to sew a cropped region of the pattern around difficult seams. And the second we call scale, where the user sews a smaller version of the seam. The details of this study are in our paper, but we want to focus on the takeaways and how they led to our design for InStitches here. In particular, we found that all practice types were effective in improving accuracy. Different users preferred different practice types, and practice takes time, nearly 1-to-1 with each additional sewing step, which means that practice can be time-consuming, so we should be careful in our recommendations. So the main part of our work focused on building a system to help people incorporate these practice tasks into their own sewing. We analyzed popular sewing guides to develop a tool for predicting the difficulty of individual sewing tasks, and then we incorporated this into an actual tool, InStitches, which augments existing sewing patterns with useful practice for difficult tasks. To use InStitches, we first select the pattern we want to make. We then fill out a short survey with our sewing skill level and information about our available fabric. We can also indicate we want to make sure we practice certain tasks, such as the hem, because that's something we always struggle with. We then enter our measurements at the bottom to create a custom size pattern. Next, we go to the main practice preparation page. On the left, we see all of the potential practice steps with some information about their expected difficulty. Recommended practice steps are checked and highlighted in orange. At the top right, we see the expected time and materials required to complete the sewing for the practice steps and the actual garment. Below, we see the pattern pieces laid out on the main fabric and additional muslin. Practice pieces are orange and actual pieces are white. We can add additional practice steps, such as step 2, by selecting additional steps on the left. We can also change the practice type using the drop-down. Changing step 3 to a muslin practice step requires us to use more muslin than we have available. So I instead change this step to another type of practice, the wedge, which uses our main fabric. We now see all of the pattern pieces fit on our available materials. We then download and print our patterns and cut out the materials. And then move on to the sewing step. On the sewing page, we follow along the interwoven practice and actual sewing steps until we produce our finished top. We evaluated InStitches with 8 participants from a local crafting club. They each sewed a tank top from free sewing in their custom size over the course of 2 hours using InStitches. Participants were free to take the practice suggestions or choose not to perform them. Most users took the suggestions, but 3 participants ended up making major mistakes that required ripping out long lines of stitching. In each of these 3 cases, we found that InStitches had actually suggested practicing the step, and the user had chosen to ignore this suggestion. At the same time, not a single step that was practiced resulted in such a failure. 2 participants explicitly mentioned regretting not practicing certain steps. P5 created a hole when they failed to catch the edge of their binding strip of fabric. They said, "I skipped the practice for step 9 that was recommended because I thought I didn't need it, but that would have been most helpful." P1 created improper overlap on the binding strip and said, "I should have probably chosen to actually practice binding on muslin at least once as recommended." And this highlights an interesting design dimension to explore in possible future work in systems that support practice and skill development. How strongly should a tool suggest practice? Our current implementation represents a particularly accommodating point in this design space. Alternatively, one can imagine an interface that hides subsequent steps from the user until suggested practice has been completed. In between these 2 extremes, one could also imagine designs that display practice suggestions alongside statistics or images showing likely failure modes for the relevant step. While the structure of sewing patterns and the language of their accompanying instructions are specific to stitching, our approach of combining domain-specific knowledge of what is challenging and making use of existing structure in making processes can be applied more broadly to other types of tasks. Other domains, such as cooking, that require people to perform tasks of varying difficulty levels in a specified order are good candidates for a similar approach. One of our study participants even suggested building a similar tool for knitting, which could leverage the structure of knitting patterns. We believe these types of systems that utilize computation to guide effective practice can go a long way in helping beginners develop the skills they need to achieve their making goals.